I'm Rana. I'm an educator with the North Carolina Aquarium on Roanoke Island, but I'm not at the aquarium today. I'm at Roanoke Sound. I'm at the edge of our Outer Banks and our wetlands to talk a little bit about ecosystems. This is a series we're calling Sea to Sound, and I'm stopping at a number of different ecosystems to talk about the abiotic and biotic components of each. Because when some people think about the Outer Banks, they think about beaches, but you know we got a lot of different kinds of ecosystems going on around here. So this is about wetlands, and the thing I want you to remember is that wetlands are rich with life. Whether you're talking about the edge of a sound, if you're talking about a marsh, you're talking about a swamp, they all have a lot going on in terms of life. But you know that life, that biotic component, is influenced by the abiotic component, the not living parts of an ecosystem. So what do we mean by abiotic? That would be something like the sun. How much sun does an environment get? Is it shady all the time? Is there a lot of sun? You can see at this environment we get a lot of sun. There's not a whole lot of high trees. The weather can influence, and so the resulting climate can influence who can live here. Is it a really wet environment? Is it a dry environment? We have a fair amount of weather in this part of the world, a lot of rain and such, and so this is kind of a rich environment for that. And lastly, we're thinking about the soil. What kind of soil do we have in this environment? And a lot of us were built on a sand dune, so most of our soil is going to be sand. So who can live here in an environment like a wetland? So when we're thinking about a wetland, kind of what's interesting about this wetland, this is Roanoke Sound, and it is a estuary, what we refer to as an estuary, one of the biggest estuaries we have, because we've got fresh water coming in from our various rivers. For our part of the world, it's the Roanoke River, it's our biggest one. But we also have influence from the ocean. Oregon Inlet's not too far from here, and so that mixture of salt water and fresh water makes a very rich environment for lots of critters to start off here. So this is a nursery for many types of seafood. You like seafood, you gotta have wetlands. It's very shallow. You can walk across over to Roanoke Island pretty easily without getting your hair wet. There's a ditch in there somewhere, but for the most part, you're gonna keep your hair dry. And we get a lot of influence by our weather, by the wind. This environment has tides, but our tides are not lunar tides like we get at the ocean. Our tides are wind-driven tides. And so if we have a strong southwest wind like we often do in the summertime, I would be waist deep in water at this place. If we have northeast winds, it would be dry a good 100 feet out. So the tide, the way the waves come in is influenced largely by our wind and vents. So let's go ahead and do a little bit of abiotic study. I got me a bucket of water from the sound. The first thing we want to check is our temperature. And so as I look at our thermometer, it is 64 degrees. Take a quick look at it, that's in Fahrenheit. This water is pretty murky a lot of the time, and so it can absorb the sun's energies in the summertime, so it can get pretty warm in this waterway. But that temperature will influence a lot that goes on, how much oxygen can be in the water, how the animals can pull out different nutrients out of the water. So temperature is a really big, important component to our abiotic system. Let's go ahead and do the salinity. This is called a refractometer. You can get refractometers that measure how much is dissolved for making maple syrup. You can get it for doing liquor or beer and things like that. But this one is designed for salt. I'm going to put a bit of water sample on this patent. I'm going to close the gate, and we can then see how the light bends as it passes through the salt. I'm going to look through the viewer, and what I see is 11 parts per thousand. So what does that mean? If I have 990 buckets of water, 10 to 11 are going to be nothing but salt, right? So that gives us parts per thousand. That's salinity. Again, salinity will make a difference on who can live here. Some animals are strict saltwater animals, some are freshwater animals. You better be adapted for both, because our salinity can change from near clear freshwater is 0 parts per thousand. I've seen it all the way up to about 15 or so. So you better be very well adapted for that kind of environment. What I like to do next is dissolved oxygen. The animals who live in this waterway are going to be interested in how much oxygen there is in our waterway. Depending on whether you are needing a lot of oxygen, so 12 parts per million, or maybe you don't need very much. But again, you better be adapted for what's coming on this environment. So what I'm going to do is get a sample. I get 25 milliliters, which I can flick off of sample. You can see how murky it is. Lots of organic stuff floating around in that water. I'm going to add a reagent, and this reagent is in a little ampule. And it's going to be able to, oops, let me get another one. Look right. Okay, so this reagent is going to react to how much oxygen there is in this water. I take off the tip of it, it pulls out through capillary action a sample, and I can invert that sample back and forth. And then I'm going to compare that to that colorimetric chart I showed you before. And so when we're looking at this, we want to kind of see, and you might be thinking, well, who cares? Well, how much oxygen is in here? Well, if you're a fish, if you're a crab, shrimp, clam, oyster, you're going to want to have a certain amount of oxygen to be happy and healthy. So I'm guessing, up to me, it looks kind of like a 6 parts per million. Now remember, we measured salinity in parts per thousand, parts per million. So 999,994 buckets of water, only 6 buckets of oxygen. Doesn't seem like a lot, but that's actually not too bad in an environment like this. Again, that could change depending on if you've got a lot of wave action, it might be higher. If you've got a hot summer day with not any wind and not any waves, it's probably going to be lower. You better be adapted for that if you're an animal who lives in this type of environment. Let me put this sample away. All right, there we're going to do one last water thing. We're going to look at the pH. Little p, big H, potential of hydrogen. And we've got 2 of these little charts that we're going to compare to. pH is measured from 0 to 14. There are no units, kind of weird. But if it's 14 divided by 2 is 7. So if 7 is considered neutral, any number less than 7 is going to be acidic. Any number larger than 7 is going to be basic or alkaline. And so I wonder if you think which color I'm going to have to use to compare. Again, I get a sample of water from my bucket. Again, temperature will influence a lot of stuff, pH included. So I got 10 milliliters of water. I'm going to add this reagent, 10 drops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Put the lid back on. Got to find my lid for this thing. Oh, I see, kind of greenish color. I don't think we're going to need, do we need the acidic one? Again, invert it to mix it a bit. Put it in my color chart. I think we're going to use the green one, green and blues. And as you look at it, you see it's kind of around 7, maybe 7.5, but pretty close to what we call neutral, so 7. Again, no units for pH. So again, that will influence how well, because what we were thinking about with pH, water is a molecule that looks like Mickey Mouse. And so if you think of that, the round circle of the oxygen and the 2 ears are the hydrogens, H2O, right? And so what we're measuring is when H pops off, does it latch onto something else, leaving a whole bunch of OHs floating around, or does the OH latch onto something and there's a whole bunch of H's floating around? And so that will influence how well an animal can pull out nutrients from the water, how well a plant can pull out nutrients from the soil. So it's important to have a certain kind of pH for each environment. Right. Last one I want to look at is to think about the soil. Again, that's one of the abiotic components. This is called a soil probe. It gives us a column of soil. I'm going to shove this in the ground. Again, we're living on a sandbar, so most of this is going to be sand. But as I pull it up, you'll see there's all kinds of stuff going on. And so this environment sometimes has a lot of marsh muck in it. The black stuff is decomposed stuff going on. If you were here, you get to get a good whiff of how stinky it is out here. But that decomposition is important for many kinds of life to grow here. So again, we got sand, wet sand. So if I push a soil probe down that was 20 foot long, it'd all be wet sand. 100 feet down, wet sand. 200 feet down, wet sand. We just have a lot of wet sand around here, right? So these abiotic components influence what can grow here. So as the camera kind of pans around, you might notice there's a lot of grasses. Grasses do really well in this environment. They don't mind having their roots buried and then exposed and then buried again. We've got Phragmites out here, which is not ideal. It's a non-native. invasive, but we also have a lot of spartinas, different types of spartinas. We've got some shrubs, again, that like to have kind of wet feet. We got wax myrtles. But you also might notice a lot of tree roots. It used to be about 20 years ago, I'd be sitting underneath a lovely live oak, but over time, that erosion rate that we have along here on the Sound is kind of knocked down a lot of these pines and live oaks and taller trees that don't like to have such wet feet. So this environment is a great place. A lot of times we think about the edge and where we live. Again, the animals that live in here, the different types of snakes and birds and such. But in the water, we've got all kinds of things growing in there. Again, the wetlands are very important, very rich with life, very important. If you want seafood, you got to have a wetland. So out in the waterway, there's a lot of young shrimp, young crabs, young fish living in the environment. A lot of submerged grasses that are very important to maintain this waterway and keep it clean. So that concludes today's episode of Wetlands, Rich with Life. Something I want you to think about, though, is a conservation message. One of the things that we're concerned about is climate change. And with climate change, what's going on is that when we use a lot of energy to heat our homes and drive our cars and do all the things we like to do, we're releasing a lot of rampant carbon dioxide that was locked up into that fossil fuel. It creates a heat-trapping blanket that makes our climate a lot warmer. Sometimes you hear climate change or global warming. How does that influence this environment? Well, our sea levels are rising as a result of that warming ocean, that warming poles of melting ice. And because of that higher level water level, it's causing the waves to do a lot more damage on our Sound side here. What can you do about it? Well, a lot of things you can do is to use less energy. Maybe to combine trips when you're driving. Maybe not have the air conditioner quite so high or the heater quite so high. So things like that can do a lot. You can do things too that you can help scientists understand what's going on in terms of climate change. You can keep track of what's going on in your yard, what's blooming, who's living there. And that can give us information about climate change too, right? So things to think about. I want to thank you for joining me here at the Wetland. Again, remember, wetlands are rich with life, and I hope to see you in another episode of Sea to Sound.